Okay, so what if our digital world actually had to obey the laws of physical time? I know, it sounds like something straight out of a sci-fi movie, but this wild idea might just be the solution to one of the biggest security problems in the entire blockchain space.
I mean, really think about that for a sec. Imagine a system that doesn't just record information about what's happening, but can actually feel a moment in time, a real physical event, and lock it in forever, making it totally undeniable. What would that change? Well, the short answer is pretty much everything.
Now, to really get why this is such a game changer, we have to start by looking at a huge fundamental weakness that exists in almost every blockchain system out there today.
You know, when a blockchain records a timestamp, it's not actually capturing a physical moment. It's just data. It's a number that a whole network of computers just kind of agrees upon. And like any piece of data, that number can be debated, it can be delayed, or even worse, it can be manipulated by someone who's trying to rewrite a little piece of digital history.
And that right there is the core conflict. On one side, you've got digital time, which is abstract, it's negotiable, and on the other, you have physical time, which is concrete, it's solid, it's unmovable. The whole goal here is to anchor that vulnerable digital world to the verifiable reality of the physical one.
So, how in the world do you fix this? Well, the first part of the solution is to basically build a completely new kind of internal clock for the blockchain. It's a concept with a very cool name, consensus spacetime. This system, which was developed by TheCrackChain, completely moves away from those old, rigid 10-minute block intervals. Instead, it totally redefines time from the ground up, and that creates a much more precise and flexible internal timeline.
The concept is actually surprisingly simple and pretty brilliant. Instead of dealing with these big, clunky blocks of time, the timeline is built literally 1 second at a time. Each second is treated as its own little unique file, and then these second files are all gathered up and packaged into a larger, certified block. You're creating this incredibly precise and adaptable clock.
But look, having a better internal clock is really only half the battle. It's still a purely digital system, right? The real challenge, the multi-million-dollar question, is how do you anchor it to physical reality?
And the answer starts with this really simple but powerful idea. The instant an event happens in the real world is an objective fact. It's not an opinion. You can't debate the exact moment a lightning strike happens. That moment just is. It is absolute and totally unchangeable.
And this is where the magic happens. It's a concept called scientific field proof of work, or SFPOW. Now, in most blockchains you've heard of, proof of work just means a computer solved some random, hard math puzzle. But here, the proof is the detection of something that actually happened in the physical world. It's a complete game changer.
So what kind of events are we talking about? Well, the system uses a whole network of distributed sensors to detect things that are physically unique and super hard to replicate. Things like a specific vibration, a sudden spike in radiation, or a distinct electromagnetic signature. These little physical events become the proofs that anchor the whole blockchain in reality.
Okay, so we've got a new internal clock and a way to prove a moment in time using physical events. Now let's see how these two amazing pieces connect to build that secure bridge between the digital and the physical worlds. The architecture is actually really elegant. First, you've got the physical layer, where this big network of sensors detects a real-world event. Second, there's a translation layer, where secure firmware instantly turns that signal into a unique digital fingerprint, a hash. And finally, this is the most important part, the blockchain layer. The nodes on the network will only accept that proof if multiple sensors reported the exact same event at the exact same instant. It's looking for a verifiable physical coincidence.
So here's the crucial difference. On a conventional blockchain, faking the time is a digital problem. It's a coding challenge. With this system, though, faking the time becomes a physics problem. You would have to somehow manipulate a huge network of sensors spread out all over the place at the exact same instant. It becomes physically almost impossibly expensive to even try.
Okay, this is a really fascinating technical solution, but what does it actually let us do? Why does this matter in the real world? This is where it gets truly exciting.
Just imagine certifying an Olympic world record not just with a stopwatch, but by anchoring that hundredth of a second to a verifiable physical event, making it absolutely undeniable. Or think of a legal contract that gets stamped with a moment in time that is physically impossible to dispute. Or for the Internet of Things, it means data coming from a self-driving car's sensors suddenly becomes fundamentally trustworthy, creating a whole new level of safety and accountability.
Ultimately, what happens is by bridging the digital and physical worlds, the actual evidence of the present moment becomes the backbone of our digital trust. Time just stops being a suggestion and becomes a verifiable, unchangeable fact.
And that's the real question I want to leave you with. What is possible when our entire digital world is provably tied to physical reality? We've just explored one incredible answer, but honestly, the possibilities are just beginning to unfold.